Today we're going to look at experimental probability, and so our goal is to learn to estimate probability using experimental methods. Now, when we talk about experimental probability, just so you know, there is a term that is a little bit newer, I guess. It's the one that's now on our new standards. It's the same thing, it's just we call it relative frequency. So experimental probability and relative frequency we can use interchangeably. So I've added that to the vocabulary. So we've got experimental probability, aka relative frequency, and we'll talk about that. And then also a simulation. And so those are your vocabulary terms for today. So in experimental probability, the likelihood of an event is estimated by repeating the experiment many times. Now, if you go up and look at your notes, in place of an event is estimated, that's where I put in relative frequency, because what we're doing there is finding the relative frequency by repeating an experiment many times and comparing the number of times the event happens to the total number of trials. The more the experiment is repeated, the more blank the estimate is likely to be. Now think about that for just a minute. You can even pause the video and see if you can figure out what would go in this blank. All right, so welcome back. And so now we're looking at filling in this blank. The more experiment is repeated, the more accurate the estimate is likely to be. And I had you all flip a coin earlier today. Some of you may have still been working on your assignment, but you could try that now. And when you flip a coin, you either have a probability. If you look at what we call the theoretical probability, it's 50%. But flip it 10 times and see if you actually get 5 out of 10 times you flip a head, or 5 out of 10 times you flip a tail. And just look at your outcomes, and then do more. And see what happens as you look at the percentage of heads or the percentage of tails, and see if it starts to get kind of close to 50%. It should. All right, so the probability is approximately equal to the number of times the event occurs over the total number of trials, and all that is a percent. And we talked about that yesterday, that we can write probabilities as either a percent, a decimal, or a fraction. Well, here's the fraction right here. It's a part out of a whole. It's the part, the amount of times the event that you're wanting to get, for instance, heads, how many times it occurs over the total number of times you flip the coin, which would be the total number of trials. Another term for that right here, we could put number of times the event occurs over the number of trials. That is relative frequency there. All right, so we have an example here. A marble is randomly drawn out of a bag and then replaced. The table shows the results after 50 draws. So we've got green and red marbles in the bag, and when they drew how many times total? Well, let's see. There was 23 yellow, 15 red, and 12 green, so that would be 27 plus 23 is 50. So there it is, 50 draws, and that should add up to 50. And there was green, red, and yellow marbles. So it says estimate the probability of drawing a red marble. And we're estimating. So this is the relative frequency of the reds. So that would be number of red marbles drawn over the total number of marbles drawn, which would be 15 out of 50. And then you could reduce that, or you could change it to a percent, multiply it by 2 over 2, and you find out it's 30%, or divide the numerator and denominator by 5, and you find that that is 3/10. So either way, it's 30%. Estimate the probability of drawing a green marble. Same thing. We'll put the number of green marbles drawn out of the total number of marbles that are in the bag. Technically, it shouldn't say, well, yeah, out of the total number of draws that you do. That's okay. And then that would be 12 out of 50. So multiply that by 2 over 2. It's going to be 24%, or 0.24. And then it says estimate the probability that drawing a yellow marble. So again, that's 23 So that's going to be 23 out of 50, which is 46%, or 0.46. Alrighty, so let's move on to the next example. We can use probability in sports, used a lot in sports for statistics. We can look at your batting average, we can look at wins and losses, we can look at how many times you hit a free throw, we could look at completed passes in football, we could talk about the number of kills in volleyball, lots and lots of different things. Hopefully I didn't leave out your sport. If I did, I apologize. But think about your sport and what it would be. Or if you don't do a sport, some other application. Okay, so the probability for the Huskies to win, we're going to write that P and then in parentheses, H win. Huskies win. So that's how we write probability, so we don't have to write out all these words. Mathematicians like to abbreviate. So that's going to be 79 wins out of all the games they played, which is 138. So they have a .572, which is 572 thousandths, or 57.2%. Probability that the Cougars win would be 85 out of 150 total games. So that'd be almost 57%. And then the last one, the Knights winning would be 90 out of 146, or almost 62% when you change that to a percent. All right, so the next example, 1 out of every 2 students will win a prize at a festival. Simulate by using a number cube and estimate the probability, or you could say calculate the relative frequency, that from 6 randomly chosen students, at least 2 will win a prize. So estimate means experimental probability, or again, it means relative frequency. So since 1 out of every 2 students will win a prize, let the number 1 through 3 represent a student that won a prize, and the number 4 through 6 represent a student that didn't win a prize. If you want to do it a different way, you may, but you have to get in all the different students and whether they won or lost. Okay, because you want to know the probability that from 6 randomly chosen students, at least 2 will win a prize, roll the number cube 6 times, which represents 1 trial. So when you do that, here's our trials, and here's our rolls. And it says at least 2 students won a prize. So remember, 1, 2, or 3 means they won. So yes, at least 2 did there. Here, another way you could write these out could be 2, 5, 4, 3, 3, 5. Yes, that's at least 2 win. And just goes through all the different ways it can happen. And so here at this particular, oh, you know what? I'm sorry. We're not looking at theoretical, we're not looking at theoretical. We're looking at, they were actually rolling a die, my bad, or rolling a number cube. So after they did roll 1, 2, 3, 4, 5, and 6 for each student, then they found out that, yes, there's a 2, a 3, and a 1. So at least 2 students won. Yes, at least 2 students won, so we got 2 3s and a 2. Here, yep, because we've got a 1, a 2, and 2 3s. And in the next one, we've got a 2, a 1, and a 3, so that's yes. Here we don't have any. Oh, I'm sorry. Wait a minute, 1, 2, and a 3. Well, I got to go back a second. I think I missed something here. At least 2 win a prize. Okay, we're going to say, let the numbers 1 through 3 represent a student that won, and 4 through 6 represent a student that did not. Okay, technically this one is not, because, okay, so I guess they just had a typo there. That should be either a 4, 5, or 6. So they're saying no. So let's just scratch that out and put in a 4, 5, or 6. Here, there was no 1, 2, or 3. So it's a no. And then the rest of them are yes, because there's at least 2. Oh, I'm sorry. I know why, because there's not at least 2. Okay, Mrs. Stevens needs to go back to bed. All right, so there is not 2, at least 2 of them. There's only 1, so that's why it's a no. All right, if we go through here, there's at least 2 on the rest. So if we look at the relative frequency, there was 8 yeses out of 10 no's. Whoa, I'm sorry. So at least 2 students from 6 randomly chosen students won a prize. So the estimated probability is about 80%, 8 out of 10. The more you do it, the closer it will become to the actual probability. And that's the end of our lesson. And tomorrow, we're going to look at, you'll be doing some problems on experimental probability. So make sure that you have your lesson filled out and you're ready to go tomorrow to show me your notes. I'm going to check them, not on, well, Monday, so whenever you watch the video. So make sure you have done that so I can check the video. And when you walk in to see me, we haven't done this in a long time, if you wink at me with your right eye before you walk in the door, or if I'm not at the door, if I forget, just come up to my desk or wherever I'm at and give me a wink. I'll give you a prize ticket. I know I'm going to give you 2 prize tickets. Have a good evening. Don't tell. That way I'll be able to tell who's not watching the video.